We will now begin our exploration on the Earth's mechanism. Can you recall the plate tectonic theory? Developed in 1960s, plate tectonics is the modern version of continental drift, a theory first proposed by scientist Alfred Wegener in 1912. The plate tectonic theory states that the Earth's lithosphere, the crust, and the upper mantle is broken up into several pieces called plates that move slowly. It explains how the massive plates move along the different types of plate tectonic boundaries: convergent, divergent, and transform fault boundary, where they interact, and the geologic events such as earthquakes and subduction, and geologic features such as formation of mountains, volcanoes, and trenches that occur at their boundaries. What makes lithospheric plates move? To help you answer this question, take a look at this figure. A convection current is a heat transfer process that involves the movement of energy from one place to another. The convection currents tend to move a fluid, gas particles, or molten rock. These are caused by the differences in the densities and the temperature of a specific gas or a fluid. Due to this temperature difference, the hot fluid tends to rise as it expands, whereas cold fluid tends to sink because it contracts. Convection is one of the kinds of heat transfer. The other two are radiation and conduction. Did you know that convection current also happens in the mantle? Wonder Warriors, let's zoom in! As we all know, the mantle is the second inner layer of Earth, made up of mostly hot rocks and magma. It is a very hot layer because of the heat generated by the core. The source of heat from the core is due to the decay or breakdown of radioactive elements. Mantle convection is a process by which thermal convection occurs in the inner layer of the Earth. The differences in the temperature of the Earth's interior and surface cause convection currents to occur within the mantle. Take note, lithospheric plates are the parts of the uppermost layer of the Earth, and they are flowing in the area called the asthenosphere. As we previously learned, the asthenosphere is a soft, less rigid upper part of the mantle where the lithospheric plates float and move around. Remember, plates move slowly and continuously when the hot, less dense material rises. The rising hot material cools down in a certain area, hence it becomes denser. Dense material sinks that creates convection cells with hot rising currents, and cool sinking currents are regularly repeated and become a cycle, to which we can attribute the movement of the lithospheric plate. The movement of the lithospheric plate is attributed to the mantle convection and considered as one of the driving mechanisms for plate motion. The lithosphere at the divergent boundary will uplift and tear apart due to the rising of hot magma. The sinking of magma pulls down the tectonic plate at the convergent boundary. Aside from mantle convection, what are other forces that move the lithospheric plates? The other forces that move the lithospheric plates include ridge push, sliding, and slab pull. Let's get to know them one by one. In the process of slab pull, the presence of a heavier subducting plate pulls down the trailing slab into the subduction zone. In the ridge push or gravitational sliding process, the old oceanic crust becomes heavier than the oceanic crust and sinks because of the weight of the raised ridge, which pushes down the older oceanic crust towards the trench at the subduction zone. Wonder Warriors, how are you so far? Don't forget to take note of the important details on a piece of paper. Remember, by taking notes, you can easily recall our discussion. You have just learned about what is happening during convection. To further understand this process, let's have this enrichment activity. It is important to understand convection's definition before considering examples, so you're clear on what convection really is. Convection is a transfer of heat related to the movement that occurs within the fluid due to the rising of hotter materials paired with the sinking of colder materials. This occurs because hotter materials have less density than colder ones. Here are some examples of convection in everyday life, including several common household occurrences. Number 1. Boiling water.
When water boils, the heat passes from the burner in the pot, heating the water at the bottom.
This hot water rises and colder water moves down to replace it, causing a circular motion.
Number 2. A steaming cup of hot tea.
The steam you see when drinking a cup of hot tea indicates that heat is being transferred into the air.
And number 3. Ice melting.
Ice melts because heat moves to the ice from the air. As a result, the ice melts from a solid to liquid.
Can you cite other examples of convection in everyday life, including several common household occurrences? Take a photo of those examples and post it in Facebook, Instagram, or Twitter with the hashtag #WonderConvectionAtHome. Remember, plates move by bumping in the opposite direction and sliding past each other, resulting in making areas of volcanic activities, earthquake, and mountain formation. Take note, the motion is driven by a convection current mechanism within the Earth. I have